The next subject we are going to study in this introductory lecture is a brief history of artificial intelligence. AI has gone through many stages in its relatively short history, and we're going to go through the stages one by one, starting from the first decade of AI from 1940 to 1950. This is actually called the early days or the gestation period. You can think of AI in this period like an egg waiting to be hatched. So it's not yet a chicken, but all the signs that it is there are there. Okay, so what are the main events that happen in this period that led to the advancement of artificial intelligence? Well, first, in 1943, two guys, Warren McCulloch and Walter Pitts, they proposed a model of artificial neurons. In fact, they produced the first artificial neural network. All right, they propose a neuron that has the characteristics of being on and off, and they show that any computable function can be represented by some network of connected neurons. They also suggested that a suitably defined network can actually learn. Okay, so this was the first time that artificial neural network was introduced. Then, of course, the other event that happened in this period was the famous lecture by Alan Turing, which is titled Computing Machinery and Intelligence. It was actually in this lecture that Turing presented his famous Turing test for artificial intelligence, which we discussed earlier. Now, part of his lecture reads as follows. He said, I propose to consider the question, can machines think? This should begin with definition of the meaning of the terms machine and think. The definition might be framed, so he went on to provide his definition for what is machine and thinking and so on. So this was a very interesting lecture that actually began to focus the attention of people towards the emergence of AI. The next period after this was the one that actually witnessed the birth, if you like, of artificial intelligence in 1956. Yeah, so it is in this year that John McCarthy, who was then at Dartmouth College in the US, he convinced a number of colleagues, Marvin Minsky, Claude Shannon, Nathaniel Rochester, to help him to bring together US researchers that are interested in the field of automata theory, neural networks, and the study of intelligence. Why did he need these people? He planned to organize a 2-month workshop in the summer of 1956 at Dartmouth, and this was his proposal. He said, we propose a 2-month, 10-month study of artificial intelligence to be carried out during the summer of 1956 at Dartmouth College in Hanover, New Hampshire. And the study is to proceed on the basis of the conjecture that every aspect of learning or any other feature of intelligence can in principle be so precisely described that a machine can be made to simulate it. So the Dartmouth conference was held, and he was able to get 10 people to attend the workshop. And one of the key things that happened in that conference was the adoption of the name artificial intelligence in the field. So this is why actually this workshop was considered to be the birth of artificial intelligence, because this was when the term was first used and adopted. Okay, the last point here is saying the conference itself did not actually lead to any breakthrough, but it helped in another way, in that it introduced all the major players in the field to know about themselves. And for the next 20 years, the field will be nominated by these people and their students and colleagues at their various universities, which include MIT, CMU, Carnegie Mellon University, Stanford, and of course IBM, because IBM was also involved. So this was one of the main outcome of that conference. Actually, it brings together these people who began to talk to each other, and for the next 20 years they helped actually to build the field of AI. Okay, let's move to the next decade, 1952 to 1969. This is the period of early enthusiasm, great expectations, because actually it was the period where many fascinating programs, fascinating at that time, of course, because people never thought programs like that could be developed. Intelligent programs like that could be developed. So a number of programs were developed during this period, which helped to make the field of AI actually more popular. So among the programs that were developed were the Samuel's Checkers program, which was developed by Samuel in 1952. So it was the first AI program to actually play a game of checkers. And it turned out that program played the game even better than the inventor of the program himself. Okay, so the program was defeating the guy that developed the program. It was also the period where Newell and Simon, they produced the logic theories program, which was a program to prove mathematical theorems. They also later produced another program called GPS, all around the same period. GPS stands for General Problem Solver. I think we discussed it briefly earlier. It was during this period that McCarthy actually introduced a language called Lisp, which became very popular in the US for developing AI programs. Okay. Another interesting program that was developed during this time was the geometry engine by Galantas. So again, this was a fascinating program that could solve geometric problems. Another one is the Robinson's complete algorithm for logical reasoning, and so on and so forth. Actually, this period produced so many surprises that John McCarthy termed it as the look ma no hands period. Look, ma, no hands. The point is, at that time, many people didn't think that certain kind of programs can be developed. So they will challenge the AI guys that they don't think this can be done, and they will prove them wrong that it can actually be done. And then they bring another one, and then that one also solved, and so on. So that was why it was so interesting period. It made the people who are dealing with artificial intelligence so confident and so full of plans for the future. In fact, this is one of the prediction that Simon made, Harvard Simon. He said that within the next 10 years, at that time, computer will be chess champion, and a significant mathematical theorem will be proven by machine. Of course, although his theory came to be true, that a computer beat the world champion, as we will discuss later, but it didn't happen in 10 years. It actually happened after 40 years. Yeah. So such was the enthusiasm at that time. But then after this, reality began to set in. So we have another period from 1966 to 1973, which is called a dose of reality. So in this period, reality began to set in, or reality began to catch up with the AI promoters. The speed of development became much slower, and the expected early enthusiasm began to fade away. They had two issues actually. One is that the early programs that they were developing, they developed them in such a way that the programs knew nothing about the subject matter that is being programmed. They were not knowledge based, if you like. They were more of general principle based. Okay? They succeeded by means of simple synthetic manipulations. Unfortunately, it is difficult to upscale this kind of programs to solve more difficult and larger problems. So there were a lot of failures. For example, one of the failure was the withdrawal of the U.S. funding in a project to translate Russian scientific papers. Initially, the U.S. government sponsored projects, to use AI to translate scientific papers from Russia into English so that their military can benefit from the findings. They spent a lot of money on this, and after some years working on this, it was realized that the AI guys could not actually translate even a single scientific paper. Because as it turned out later, language translation is not a simple matter of synthetic manipulation. It actually requires a lot of background data and pattern recognition and so on. So they couldn't do it at that time, and therefore the funding was withdrawn by the government. Now, apart from the problem of the design methodology of these programs, that they didn't take the subject matter into account, another problem also arose. And that problem was the interactability of many of the problems that AI was attempting to solve. The problems were intractable. Too much computer resources are needed. Okay? Uh, so this was discovered after the theory of computational complexity was discovered. Okay, because initially they thought the small programs that they were developing can be extended to solve larger problems by simply developing faster computers with more memory. Unfortunately, it turned out to be not the case because, as we learned in the other course, analysis of algorithms, there are certain problems that cannot just be solved. So far, no efficient algorithm has been found. And those actually were the type of problems they were trying to solve, and therefore they failed. So similar to what happened in the US, also happened in the UK, because the UK government was sponsoring a lot of research in UK universities, research related to artificial intelligence. But when it was discovered that the development of AI at that point couldn't actually handle these larger problems, then the funding was withdrawn by the government. Uh, yeah, so this was a period where there was a real uh, setback, but people kept going. Let's move to the next stage. 1969 to 1979. This is called the knowledge-based systems period. The approach to problem solving during this initial decade of AI was to use a general purpose searching mechanism that uses elementary reasoning steps to try to find a complete solution. Now, such approach turned out to be not sufficient, and therefore it is called weak method. In this period, 1969 to 79, they began to explore another alternative method. Yeah, so this alternative method is to use domain-specific knowledge. Okay, instead of using general principle, no, use the information you know about the domain, and that will allow you to have larger reasoning steps, and therefore in your searching algorithm you will be able to find your goal much faster. So this was the period where this methodology was discovered and things began to move again. Okay, so that led to the development of expert systems, and a number of expert systems were developed during this time. The first one that became famous was Dendral. This was a program designed to infer molecular structures from mass spectrometer, which many people at that time were surprised that that could be done. But because the system has a lot of domain-specific knowledge, they were actually able to achieve that. Another example was the MyCin program. This was a program for diagnosing blood infections. Okay, so again, an expert system related to medicine. So it knows a lot of information about blood, and therefore it was able to do the diagnosis. Another example is the prospector. This is another expert system that is used for decision making in mineral exploration problems, and so on and so forth. So that was the knowledge-based system period where people really began to use domain-specific knowledge to develop AI programs, which are then referred to as expert systems. The next stage is the 1980 to 1988. where actually AI became an industry on its own. This is the period where the first successful commercial AI system was developed. It was called R1 by a guy called McDermott. This system was developed for a computer company called Digital Equipment Corporation, DEC, and it was designed to automatically configure computer systems. All right. So it became very useful to them, such that by 1986, this program was saving the company about $40 million because it does all the configuration automatically on its own without involving humans. All right. So that was when companies began to actually explore the possibility of using expert systems to help them in their operations. And very soon, by 1988, nearly all major US corporations they have either an expert system developed for their company or they are investigating the process of having one to support their operation. So AI really became an industry in this period. It is also in this period, in 1981, that the Japanese government proposed a program they call fifth generation. So this was a 10-year plan to build intelligent systems for the Japanese government. And seeing the importance of that plan, many other advanced countries like the US and the UK, they also followed suit with similar plans. So in fact, the funding withdrawal by both the US government and the UK were reversed in this period. Government began to again fund universities to work on AI projects. The next period after that is 1986, which marked the return of neural networks. The neural networks, as we discussed before, was discovered much earlier, but it was abandoned at some point because they realized it could only solve at that time limited kind of problems. However, during this 1986 period, they discovered a process that could be added to it to make it more powerful. One of it is the back propagation, and the other aspect is adding more layers to the network, and that helped make it much more powerful. So seeing that now it works in solving more complex problems, people began to adopt neural networks again. In fact, now a neural network has grown so big, it has created a field of its own, which is called deep learning, where they have these huge neural networks with so many layers that the network can be used to solve huge kind of problems. All right, this is the kind of network that is used by Google in some of its applications. 1987, AI became a science. Now, previously, AI development was achieved through the efforts of individuals whose experiments were not really validated, and there was no way to replicate that experiments elsewhere because there was no data, no code to compare, and so on. However, by 1987, things began to change. the methodology of AI, people began to follow the scientific norms, where before an idea can be accepted, it has to be subjected to rigorous proof and so on. So this began to happen with the community, with the AI community. They began to be more open to scientific review. It is also now possible to share data and code, so people could repeat the experiment in their own university or site to see that it is working. Yeah, so this was when AI actually began to be a real science. And the last period we will talk about is the 1995, the emergence of intelligent agents. It is at this time that it became clear to AI practitioners that it is not necessary for an AI system to behave or to think like a human. Yani you don't have to make it to think like a human. The main thing is to have an intelligent system that can solve problems. So they began to adopt the idea of this agent thing, where an agent will be able to perceive its environment, will be able to learn new things, and will be able to act in a way that achieve goals. So the main thing is to be able to solve problems, not necessarily to mimic the way human beings work. And this is now the main focus of many AI practitioners, rather than the original idea of trying to mimic the human mind. So this is basically the brief history of AI. The last topic we will look at is the state of the art. So in this section, we will just go through some of the important milestones that AI has achieved to make it a really important field in today's information technology world. One of the first big development was in 1997 when the IBM's Deep Blue computer defeated the reigning world chess champion, Garry Kasparov, and it became a big news throughout the world. All right, first time a computer was able to beat a world chess champion. Another development that surprised many was the development of an AI computer program that proved a mathematical conjecture, which is called Robin's conjecture. This conjecture was unsolved for decades, but here you are, an AI program was able to prove that conjecture. Another event that happened in the US was the No Hands Across America event, where a vehicle drove across the length of the US from Pittsburgh until San Diego, a distance of 2,850, almost all of it on its own, autonomously. And the car drove itself for this much distance. Only 50 miles out of the 2,850 were not driven by the car on its own. So this was a big achievement, especially in the context of developing self-driving cars that is now becoming a commonplace. Another big development was during the Gulf War in 1991, where the US forces deployed an AI logistics planning and scheduling program. that involve up to 50,000 vehicles, cargoes, and people. And they were able to manage all of this successfully. It will have been much, much harder to plan that war without this AI system. Okay. Then, of course, we have the NASA's onboard autonomous planning program that control the scheduling of operations for spacecraft. Another important AI program was the ProBAF. This is a program that solves crossword puzzles much, much better than a human can. All right. Okay. Now, if you consider the no hands across America challenge as a big development, this is even better. The Stanford vehicle participated in the DARPA challenge. Now, the DARPA challenge was also about driving autonomous cars, or about cars driving themselves autonomously, but this time not on highways, but in the desert with multiple obstacles, no clear road. Okay, but this vehicle was able to complete that challenge and did 132 miles on its own in 6 hours 32 minutes. So this again was greeted as a very big development. I'm sure you have many other examples of your own where AI has really proven to be a fascinating field. I just end here with a video for you to watch. It's a presentation of Google I/O, where Google was showing some of its AI programs. The last thing I want to say is that I hope this has given you an introduction of where AI come from and where it has reached. The hope is that by the end of this course, you will be able to learn some of the techniques that helps AI to achieve this fascinating state that it has reached. We will stop here. Thank you very much.